Okay. Hello, everyone. Welcome. How's it going so far? Everything's okay? Are you enjoying the conference? How many of you is ready to drinking? Just me? Oh, come on. Oh, thank you. Welcome to the bar. So today we're going to present the most complex title ever. That is basically Edge Intelligence Unlocked, combining AI, Gen AI, IoT for industrial excellence. That basically is just the 30 minutes, so thank you for the speech. Goodbye. No, actually, we were supposed to run a demo. Unfortunately, as you probably know, there's some issues with the connection, with the interconnection today. So for all those that will be interested in the demo, especially the generative AI demo, will be run tomorrow morning at the booth for us. So sorry about that, but I know and I'm sure that it will be super interesting anyways, not because of me, but because of this wonderful lady here that is coming from an unknown startup, probably you never heard of. It's called NVIDIA something, I don't know. Have you ever heard? No? I know, I told you. So who is Eurotech? Just really 2 seconds. So Eurotech is a global company. We are on this stage since 30 years now, so it's pretty old. 400 people, globally dispersed, headquarters in Italy, facilities, R&D facilities, mostly in Europe, in Germany and Italy as well. As said, we did a lot of few things in the history of computer, starting from 1992. Actually, it's not in the slide, but we've been the first company to build a wearable computer. And actually, at that time, we have to choose between 2 operating systems, Windows CE and something called Android. And we smartly decided that Windows CE was the future. Yeah, sometimes you don't make really smart decisions. Anyways, between the other things, we do a lot of things like we've been in the Eclipse Foundation since ever. We collaborate to develop MQTT. Then we start from the boards up to integrated hardware and software, to some nice open source software that I will mention during the presentation, up to be the first device cyber secure certified through IEC 62443-4-2. If you don't know what it is, please feel free to come to the booth and we'll give you like a 3 hours explanation on that. It will be super boring. It will be absolutely no science, but no worries, we will have a lot of fun. And finally, we are an NVIDIA partners. And with that, actually, I'm introducing Christina, that is my partner today. And I'm not going to say what we said before, you know. That was welcome to our weddings. Thank you for coming today. But she will present NVIDIA point of view on not just, I think, Jetson devices, but on AI. So up to you, Christina.
Good afternoon, everybody. Thank you for Eurotech inviting me this wonderful opportunity for speaking to you about NVIDIA Jetson. So I'm the audience sales manager who's located in the Netherlands and taking care of our partners. For example, Eurotech is one of our partners who we work closely. So,
Yep.
Okay. So today's slides. First of all, I will have a briefly just let you know the market opportunity of the AI at the edge, and then the introduction of the Jetson products, and then the software, which is one of our specialty of the Jetsons, and I'll close my part with some Jetson successful stories in hope to trigger some inspirations. First of all, I guess we all know, what Edge AI has to offer. So it's projected to have about 13 trillion by 2030. And for NVIDIA Jetson, so I think most of the time I came across is people are not aware that Jetson is a software-defined AI platform. So you can see on the corner side, you see the Jetson modules. They're actually modules. It's not like AI chip or something like you're thinking of. So how is Jetson different from our competitors? It's actually a software-defined. We have different SDK, design tools, which our developer likes them so much because they are mostly free for people to use. And one of the things that was mentioning is that ecosystems. So we have the sensors, AI framework. For example, you can see the robot computer offered by Eurotech. They are available at the booth. These two models is Relia Core 3311. The other one is 3111. They are live demoing at the booth. So please, if you have time, shop by the W16 booth. And also we have the solution providers and then the cloud service. So all these ecosystems are certified by NVIDIA. So it's like a one-stop shopping. Like, you don't buy something that you end up like, thinking you have to get this and that. No, we have an umbrella, get everybody covered. And at the moment, we have about 1.2 million of developers. This is not NVIDIA employees, actually developer using NVIDIA Jetson for developing their applications. And about 10K plus end customers. And you can see that NVIDIA Jetson covers wide ranges of the different application users. And we are working with most of the well-known one like Komatsu, Toyota, and No Traffic Israel, Mir, Landing AI, etc. So how does NVIDIA Jetson solve the edge AI development pain points? I'm not going to go through all of them, but I think many of us knows that developing the AI model can be rather time consuming, and also there are a lot of hardware, software ready products. And for example, like carrier board, full system sensors, and also it does takes time to have the AI model to adapt to the target platform. So how do we solve that? We actually have a software that's dedicated to each different verticals, which I will go into detail in the following slides. And we actually have a pre-trained model library as well that's freely for the end user to download and use and build their own model on the top of it. So nothing is starting from the scratch. And also the ecosystem, which I stressed in the beginning of the presentation, that is at least about 150 systems that's ready, and then 600 plus competitor cameras and sensors. And like I mentioned earlier, that Jetson is a system on module. So it's not just a chip, it's as SoC, memory, power management, and I/O expansions. And this slide is showing you that what is Jetson to offer from the software side. So we have the pre-trained models ready for the end user to download and adapt to it. And then we have the TAO toolkit to help the user to build their AI models in accelerations. And also we have a specific vertical driven SDK. For example, ISAC is a robotic one, and DeepStream is to help people help the developer to train their AI, and Riva is for language SDKs. And we have the Jetpack. It's more or less like your iPhone iOS is updated twice per year, and which I can show you the roadmap in the following slides. Yeah, so Gen AI, I guess everybody I wouldn't go into detail about it. It's like, you input in different type of context, it will create a new one rather than the traditional AI. I think most of us have the ChatGPT installed their phone, so we know what it is. And then you can do different model, LLM or VLM for Gen AI. But more importantly, I want to talk to you about why Gen AI on the edge, because I think most of the people, when I talk about Gen AI, people think, it's on the cloud or something. But when you think about having it on the cloud, you are exposed to certain kind of threats, for example, hacking or, privacy leaks or something. But if you have it at the edge, first of all, it can be more cost efficient, and then you can have your data encrypted to avoid such a problem which may occurs on the cloud. And some of the use case I can think about is perhaps like factories. You don't need to have that on the cloud, right? You're just monitoring the factories. Whether there's any casualties or something like that. You can have the manager in charge. You just ask the command prompt something like, is there any casualty happened today? Is there any something fault? And then it will show you, the reports of what happened on the day. That doesn't have to be on the cloud. Yeah, so we also offer this NVIDIA Metropolis microservices for Jetson. So this also comes with the Jetson. When you purchase it, then you get this. And for how to build on that, Alex will come to you in the following slides. And this is the Jetson family. So starting from the I think that's the left-hand side. Yeah, so Nano is the the entry version, the cheaper versions, and towards to the performance, which is the AGX series, our more the heavy duty one. And on the bottom hand side, you see those one in gray shades. It's not like they are gone or something. They're just legacy products. And the current one we have is the Orange series. And at the Eurotech booth, we have the Orange NX and the AGX Orange on running. So if you're interested, please, drop by and take a look at it. And we are announcing I don't know if anybody watched the GTC, which we had in earlier March this year. If you haven't, it's still available on YouTube. I know it's very long, so you can just check the summary, some YouTuber make it, so you can watch it in 20 minutes. So Jensen, our CEO, actually announced these products, AGX Thor, as a Blackwell architectures. And you can see, obviously, that it's a very heavy-duty product that's aiming for the humanoid robots. And it's available perhaps by the second half of 2025. And if you are interested in these products, you can, of course, ask our edge partner, Eurotech, for it. And this is our ecosystem partner, and then you can see that Eurotech is one of our partners who we are working closely for the hardware and design services. And this is the Jetpack roadmap, and you can see that it's scheduled for 2 releases per year, and the 6.1 is not yet available. I think it's a slight delay, so it should be available sometime by this month. I keep my finger crossed. And I think one of the things that we are a bit different from from other competitors is that we have these online forums, which most of our developers likes a lot because it encourages the discussion between the developers. And all these forums are monitored and then mentored by the NVIDIA engineer on 24/7. And you can, of course, submit your questions and tickets, and there will be people taking care of you. And it has been proven very successful, and then the developer loves it so much. Yep, here comes the successful story. So we identify 6 major industry which we are working for, and we have successful stories based on all these ones. However, I pick some of them which is more, I think is quite interesting to share with you. First of all, this one is airport management. I understand, the text is so small, I don't think anybody at the back can see, but it's I just quickly read you. It's a London Gatwick Airport. So what happened is they used the Jetson AGX series to determine, how fast the people are unloading, and then unloading the airplane and disembarking, and then embarking the flight and then boarding the flights. They measure how fast it is, and then to determine what's supposed to be improved. And this has been a very good example. It's already been deployed on London Gatwick about, I think this is more than 4 or 5 years ago already. And then we are continuously working with major airports in the world around for the airport management. And this one is the defect detection. So it's an AOI using Jetson Xavier NX to determine that the fault, and then the AI project development time by 60. It reduced the overall AI project development time by 65% because we already have the pre-trained models. And then if you want to learn more about AOI applications, Eurotech has the AOI running, live demo running on their booth, so you can see this one on live. But this one's by Landing AI, but it's more or less similar demo. And this one is a floor video analytics. So it's a computer vision products and application just to check that whether the staff in the factories are compliant. They are not, doing something that's causing it dangerous and then problem having at the factory ground. And I guess this one is probably the ones that we are very familiar with. So in Europe, I guess mostly we have these rubbish sorting robot arm machines that's deployed, and then sorting out the ones that are recycled and which ones are not. And this has been rather, I think, popular in Europe especially. But where in places like Asia, when the human resource are not so expensive, and then they have lots of manpower, then this one is probably less of the concerns. All right, I'll hand over the presentation to Alex to let him walk through you about what is this Jetson to offer.
Yeah, no pressure at all. Thank you. No. Thank you, by the way, Christina. So just to set up the stage, before actually deep dive into the most complex things ever that I don't know, I'm just speaking about. How many of you heard about NVIDIA Jetson family before today? Can you raise the hand? Okay, good. How many of you deploy, develop, play with computer vision before today? Okay. How many of you, no, please stay with the hand raises. How many of you actually deployed that in production? How many of you actually got in production and it works? I'm sorry. I'm sorry, just me and you. No, thank you, not just that. The production start, no worries, nobody else is the production actually working ever. That's the thing. So what we try to explain today, and said, we got the demo, we would like to show you the demo, but what we try to explain is, can we make it more simple to move from development to production, especially when it comes at edge? What means when it comes to edge? Now, edge is slightly different from a data center solution. Edge means multiple of same kind of devices, in order of hundreds, in order of thousands. Think about smart cities. Think about multiple facilities where you have to deploy multiple of them, and you need to be consistent. You need to be sure that all those devices, that sometimes are different each from the other, sometimes you have more powerful ones and less powerful ones in different facilities because of business reason, because of the kind of facility, because of the model you are going to run, they need to be consistent each other. And you want to combine a complex use case. In the title, we mentioned IoT, we mentioned computer vision, we mentioned generative AI. To give you more samples means that maybe I want to run something that can see, describing what it sees, compare what it sees with the internal documentation I have or with the internal information it has, maybe with some analytics, combine and suggest me the best course of action. This means that I'm running probably an LLM, maybe a multimodal LLMs, a generative AI LLMs that allow me to do what we call a VLM, video language model. It combines it with the standard analytics system, and it combines it also with the standard analytics. We grab input from different sensors. The word is not just computer vision. The word is more by multiple kind of sensors. Thermal sensors, vibration control sensors, humidity sensors, maybe a multitude of them. And again, in the order of magnitude. So I can do that. I can simplify your life in a way that actually you can easily do a POC, easily do a development research, and then move it toward the production, and possibly maintaining that. Because that is the other challenge you have in production. Things are not meant to stay as it is forever. Even a model will never stay as it is, because the data is changing. And because the data is changing, the model will start to fail at some point. And you have to retrain sometimes, you have to replace sometimes, even your standard application has to be maintained. And you have to do this on a remote system spread somewhere in a smart cities. How many cross-lights did you see today? How many of them could be smart cross-lights with a small camera that optimizes the cross-light, the duration of the light just because of the traffic? That means that you have an edge device for each one of them, or some of them, on each junction in a city like Amsterdam. Count them and think about how many things you have to deploy and how many things you have to maintain. And all those things have to run your single quantized model in them. And someone has to deploy there, and someone has to connect to them, and someone else has to find a way if someone else tries to hack them. How they hack them? Have you ever gone around with a screwdriver and tried to hack into one of those cabinets around, where there's people from Italy that tends to do weird things when they travel? Not me, it's just my race. Oh, by the way, I'm just, for your own safety, I discovered over the time that apparently 20 minutes from Italian time is different from 20 minutes from the worldwide time. So if today we are still here, just let me know. So what we do is exactly that. We do edge devices. So we are a boring hardware company. For all the software people, I feel your pain. I come from software. It's hardware. There's no way to make it funny. It's just hardware. But it's hardware that is meant to work in extreme condition. And with extreme condition, you can say, like, what if I deploy this hardware in a place, in a city, since we were speaking about smart cities, in a city where there are sandstorms. And sandstorms actually are pretty nice, because sand tend to get into your device and break it up. Or maybe the device stay on a boat, and so need to be care of the fact that if water comes in, possibly not, but water comes in, still work. Or maybe is in an extreme condition where there's high temperatures. So we do these kind of things. Fanless, ruggedized, secure, possibly certified. But we are an hardware company with a value. And the value we provide, that we try to explain, is these purple things that we are here. We offer middleware of software that is meant actually to solve the most complex part of your use cases. And today, the demo that we were going to run, or actually what we are going to explain, is exactly explaining this. So this middleware, how it works, how to make these steps easier, what it means. Oops. So the first step is, in a complex scenario, I have to connect a multitude of things. I have my sensors, my data comes in, whether it is a camera, whether it is a standard sensor, whatever it is. Data comes in. I have for sure my model that I have to run. I have to check everything there, all the metrics, not just from my device, but also from the devices that are connected to me. I have to run applications, and in this specific case, this is an open source project we made that I will share with you at the end, just to explain how you can run your own generative AI example on a device, possibly on your Eurotech device. So I have a generative AI model as well, and I also have to take care of how my data eventually go out from my device. Because Christina mentioned before, the benefit of using edge is that you don't need cloud. It's true. But in the end, the reality is that at some point you want to push your data out. Think about traffic management violations. I can put an edge device on top of a car or a camera and grab the violation that I see on the street, on the road. I can store that on a device, but at some point maybe I don't want to store everything that I want to push it out. I want to push it through the central system to get you the fine, basically. So there's always this connection, northbound and southbound, and you need to have something that allows you to connect through it. And this is exactly what we do. So, whoops, sorry. Do you, I don't see here, so, yep. Okay, maybe works, okay. So, if you see it move, it is because it's moving. It's not that you are ready for drinking, it's just moving for real. So those are the steps that we just described. We said, okay, I want to run whatever AI model I have, and I want to run it against a stream of data, or maybe on-demand data, possibly on a secure platform. And maybe I want to share a camera among the resources, and I want pre-process and post-process the data with no code, or maybe with low code. And I want to run against a complex group of systems ready to use as a components, as a modules. And finally, I also want to do this at scale. I want to update at scale these systems. How can I do that? With one single slide. I know it's small, it's on purpose, so you don't understand what I'm saying and you can believe me. That's actually the trick. No, because there's too many things here. So, first of all, as you can see, there's a lot of integration with NVIDIA. Not necessarily we work only with NVIDIA, but we have a deeply integration with NVIDIA. This slide is already outdated because now it's being replaced with the NVIDIA NIMs. So the new microservices from NVIDIA are currently embedded basically in our system. What means? The needs from NVIDIA is because some part of our portfolio runs on NVIDIA cards, whether it is a Jetson family, this is an embedded system, whether it is a discretionary GPUs, so the standard GPUs like an A2, an L4, an L40S, and etc. We can go up to a H100 if you want. Well, we can discuss if it's still edge, but technically speaking, it's still edge. So the first step is, okay, I have probably some multimodal data insights. In this case, is a video. This actually is more or less the demo that we have at the booth. The video basically kicks in a stream of data. So I'm using DeepStream to optimize this data against the GPUs. The difference is basically you can use GStreamers or you can use Grabber. The difference is that GStreamer and Grabber will use probably the CPUs, while DeepStream use the GPUs of your machine. So it's optimized the workload, right? So the workload is optimized. This way, in a really nutshell, you have more performance, you are faster, you can have more frame rate per second, and etc. So you have benefits just out of the box, doing nothing basically. Then you pass this DeepStream against your model. In this architecture, what you're doing is say, I have my model, I need to run the inference, and to infer the model and understanding what is actually the machine is see, I use NVIDIA Triton. Now, Triton is a pretty interesting project from NVIDIA, and is open source. Why is it interesting? Because you know, how many of you knows that Triton can run against CPU? That you can actually run Triton on a system that doesn't have a GPU at all. Because that's the beauty of this project. Of course, it's perfect and work perfectly with a GPU. But if you have a CPU, you can still use Triton. If you have a model developed with OpenVINO from the Intel guys, and you have Triton on a CPU with OpenVINO, you can still run it, and it's still optimized. So it's pretty handy in this context, because it's pretty flexible. Now, of course, I said, with GPUs, with NVIDIA GPU works better. So we use Triton for this reason, because we don't produce only necessarily NVIDIA-based computer, but also for another reason. Triton has this capability to support a multitude of models developed in different languages. So if you use ONNX, or you use TensorRT, or even OpenVINO itself, it can understand that, and it can still infer the model. So again, it's pretty handy in this case, because it means that I already solved the first complex problem. I don't care, well, I don't pay too much attention the way I choose to develop the model. It will run optimized anyway on the hardware. And it can do that because on my hardware, the middleware, ESF, this is the name of the middleware, Everywhere Software Framework, embed Triton and DeepStream. And if you don't have DeepStream, as a GStreamer. But as Triton, you don't have to install it, you don't have to configure it, you don't have nothing. You only have to give me your model name and your file, and your job done. So the first step is that. So acquire, done. Process, first step of process, already done. But process is not just inferring. It's not just, oh, you got a model, you infer the model, that's it. Process is more complex than that. Complex means that I'm here, but I'm moving, and we have a live demo for that, on a low-code platform where I can describe the use case in a logical way. Think about boxes that are connected through arrows, one to each other, that says, when the data comes in, you will infer the model. Once the model is done, maybe you have a robot demo. Maybe you want to go against your generative AI model to start working with the generative AI. If it doesn't work, do these other things. Maybe stop the model, I don't know, maybe come back. The frame rate is too high, the frame is not clear, come back, acquire another frame. This is the way you describe it. So you use a low-code platform to do that and actually control. In this case, you control a robot arm. That is exactly the live demo you have at the booth. And at the booth, you see the robot arm will start to pick up things and put things away. Just because the model said, this is a good piece of production, this is a wrong piece of production, so put it away from the convey, please. So you infer, and you connect what? You connect sensors. How you do that? Well, how about if I tell you that ESF is open source, and I tell you that it is in the Eclipse Foundation, under the name of Cura with the K. So as literally thousands of extensions developed by the community, even ESF, that is an enterprise version that we sell as a Eurotech, is extensible. So there are people like my colleague here, Marco Vinci, actually, their job is to extend ESF for the customers between many, many, many other things. He's the smart guy. Now, don't ask me why I'm here and he's the smart guy there, but anyway. But it's extensible, means it can be applied to your scenario. You have a special sensor with a special protocol. We support over 30 field protocols, CAN bus, Modbus, and etc. Maybe you have a special protocol. You can develop and extend this platform to adapt to your own use case. But what this means in the context of AI, we just said, hey, I have an AI model, hey, I want to run generative AI, but the most complex challenge you have to solve first is, how do I grab the data to the generative AI model? How do I grab the data to my computer vision model and make it in a way that this computer vision model actually can really read it? Because that's the problem. That's the problem you have, and that's the problem we solve. Developing a model, I'm not saying that it is easy, but developing a model is probably something that in this conference, half of the people in this conference know how to do that. The problem is, how do you connect the data to that model? So this is the last step. Okay, I know how to read the data. I know, technically speaking, is the easy part of the northbound to go to the application. And to the application means the application can run maybe on the same system. You simply deploy the application as a system because, for example, again, how your application is being developed? These days, that typically means you run it in a container. We manage the container. We manage the container runtime. Whether it is Containerd, whether it is Docker, whether it is Podman, I don't care. We manage the container runtime. You don't have to install it, you don't have to configure it, you don't have to tell it to use the GPUs and etc. We do that for you. It's a module. You enable the module, you pass the container, job done. So in a nutshell, you already solve all the complexity. But it's not just that. Because, as said, we need to do this at scale. And here's come Everywhere Cloud, that again is an open source project under the name of Kapua, always in the Eclipse Foundation. His job is exactly to say, I have thousands of devices. I need to be consistent on each one of the devices. I need to create policies to access to those devices. I need to deploy your model on this device and be sure that it will be run against Triton, the Triton will be up and running, the model will be inferred, and etc., and etc., and etc. And at the end, your 1,000 devices will run exactly the same application or different set of application, whatever it is, but it will run consistently there. And that makes basically your life. Now, this is where the generative AI comes in context. Where do you deploy generative AI today? Where do you think you deploy generative AI? What kind of device you're going to deploy generative AI? What is a generative AI kind of system? And LLMs. I'm pretty sure that is in the audience, all are thinking about large, big systems. Oh, LLMs is just for data centers. Oh, LLMs is just for super huge systems. This is 100 billion parameters above as a kind of model. True. And is super precise, and is super accurate, and etc., and etc., and etc. But how do you use generative AI in the real world, in the production area? You use it with chatbot assistants. You use it with multimodal assistants. You use it to view, and etc. This is a quantization of that model. Means you reduce from 100 billion parameter above to 8 billions, 30 billions, 40 billions. Where those are supposed to run? On the edge devices. Because you deploy probably your virtual assistant on every single facility to combine it with your internal documentation. This way, the people that are working in the facility can go there and ask, how do I do this? How do I assemble this? How do I do the other this? Or maybe it's proactive. He can overlook the video, see if there's a safety issue, and proactively alert and say, hey, this worker actually is working in a area where he's using a phone where he's not supposed to use a phone, etc. Something we do today with computer vision, but you can be more proactive. Why wait things to happen when actually you can be proactive there? And these run on the edge devices. That's why we use generative AI on the Jetson devices, because we have enough computational power, we have enough consistency and capabilities, and we combine them with the middleware that makes your life easier. So, as promised, and I said, at this point I was supposed actually to run a demo and go through the demo and etc. Hopefully the Internet of Things will be fixed by tomorrow morning. We will have the demo at the booth. So I apologize for that. Please come to the booth and we'll be more than happy to show you the demo of the generative AI. The other demo, the IOI demo with computer vision, is already there. So if you follow me this way, we can actually see that. Now, I leave you with this. I promised and I said, can we please run a generative AI, not just the demo, but on our own, on a piece of hardware? Now, this is done on top of hardware, of our hardware, but it can be run on top of every hardware that is running Linux. Basically, is free and open source, is on GitHub, where the crazy and amazing things lives, typically. This is basically the 10,000 feet level architecture. So it's using Olama, in this case, NVIDIA NIMS from NVIDIA, and a pipeline that is being developed by the amazing people at Eurotech, Marco Vinci, Luca Dazzi, and Marco Buzzolini, that are the three names of the people. I know you don't know them, but trust me, I'm here because of them. That what it does? Well, it's a really simple Copilot demo. You issue to them a documentation, a set of documentation, in our case, the Eurotech documentation. It will index the documentation and will create a virtual assistant that can reply to your question. In our demo that possibly tomorrow you will see, we can ask the same questions with or without RAG. Means, without RAG, it will be a generic questions, so it will have to search over the internet about something specific in our manuals, and it probably screw up the answer. Then we will issue the same questions against the indexing of our manuals, so we can avoid using internet. In that case, we will get exactly the specific answer to the specific reason. And when I say question, means really complex question about our devices, like how do I install, or how do I create, or how do I secure the device in that specific reason, and we give an answer. And that's basically something you can try on your own, understanding how generative AI can run on edge devices. And thanks to NVIDIA, you can have an NVIDIA Jetson development kit, and you can do it if you want. Otherwise, you can use whatever you use. With that, and I think before time, no, almost in time, no. So by Italian time, actually, I'm 5 minutes before. But anyway, thank you for listening. And again, apologize for the missing of the demo, but feel free to pay a visit to us. We will offer you nothing, just words. But if there's any question, you're welcome to ask, and I'm more than happy to answer them. Thank you again.